Good morning, students. Chapter 8, Gravitation. Yes, in this lecture you will see Kepler's law. Okay, Kepler's three laws. First law, it is called law of orbit. Law of orbits. Why it is called law of orbits? What is its statement? See. All planets revolve around Sun in elliptical orbit. All planets revolve around Sun in elliptical orbit with Sun located at one foci of ellipse. And yes, I think we have discussed about this first law of Kepler, that is law of orbits, as it gives type of orbit. It is called law of orbit. Okay, yes, we will also draw its figure. Okay, here it is Sun, and yes, here it is elliptical orbit. So suppose any planet P, any planet is revolving in such elliptical orbit, Here it is Sun as one of the foci. Okay, so yes, it is ellipse. Clear about this? Okay. Now about this ellipse, you have to remember some points. Okay, it is point B. It is point A. This point B, here it is point P, here it is point A. Okay, this point P, it is closest point. From Sun, and this point A is furthest point from Sun. Clear about this? 2 points. Point P is closest and point A is farthest. Okay. This point P is called perihelion, and this point A is called aphelion. Okay, so yes, you have to remember these 2 points. Yes, you have to remember these 2 points. Okay, what is perihelion and what is aphelion? Okay, minimum distance, it is maximum distance. Okay, so yes, first law that you actually know, that is law of orbit. All planets revolve around Sun in elliptical orbit with Sun located on one of the foci of ellipse. It is this. Okay, and yes, it is called major axis. It is called major axis, and its length is 2. Okay, now we will see second law. It is called law of areas. Remember chapter number 7. Yes, chapter number 7. Conservation of angular momentum. We have proved one equation for planets revolving around Sun. Okay, whenever planet revolve around Sun in elliptical orbit, we have proved, okay, dA upon dt is equal to constant, and dA upon dt means it is line joining Sun with any planet sweeps equal area in equal time interval. Here first of all I will write statement C. Here line joining any planet with Sun sweeps equal area in equal interval of time. in equal interval of time. Okay, line joining any planet with sun, so it's equal area in equal interval of time. It means, see, sun at one of the foci, let it is elliptical orbit, for example, that it is elliptical orbit, for example. Okay, suppose planet is moving from this point P1 to P2 in time delta t. So see, line joining sun with planet, line joining sun with planet. Yes, it is moving in this direction. Okay, so initially it is line joining sun with planet. Now as it is moving, as it is moving, as it is moving, as it is moving, in delta t time, area swept by line joining sun with planet, it is this. It is this. Clear? Okay. Planet is moving from P1 to P2 in time delta t. So it is area swept by line joining planet with sun. If planet is here at P3 and in time delta t, same time interval, no? Same time interval, it is moving from P3 to P4. Then again, line joining sun with planet, line joining sun with planet. See, in time delta t, it is area swept by line joining sun with planet. It is area. Okay, so see, according to this law of areas, see, line joining any planet with sun sweeps equal area in equal time interval. From P1 to P2 it takes time delta t. From P3 to P4 it takes time delta t. It means these two areas are equal. These two areas are equal. Clear here? Hello? Okay. Area S P1 P2 is equal to, here it is area S P3 P4, because they are area swept by line joining sun with planet in equal time interval. Now see, what is reason behind this? Whenever planet is far away from sun, its speed is less. Yes, and whenever it is near, its speed is higher. Yes or no? Yes. Okay. If planet is away from, at large distance from sun, its speed is less. Okay, it is moving slowly, and here it is moving fast. Okay, so it is reason behind this. And yes, obviously we have proved this. Remember, okay, for planet, we have obtained one equation, that is dA upon dt is equal to L upon 2m, and dA upon dt is equal to constant. We have proved this dA upon dt is nothing but, see, area swept by line joining sun with planet in equal time interval is constant. It remains the same, and it is also called aerial velocity. It is called aerial velocity. It is called aerial velocity. Clear about this? So yes, law of areas. What is law of area? Means line joining any planet with sun, so it's equal area in equal interval of time. Reason: away slower, near faster. Okay, areas with this is equal to area this. Okay, and as it is its equation, if there are any question. Okay, yes, dA, that is area swept, time, L angular momentum, that is 2, and M, that is mass of planet. Okay, so yes, we have discussed the two laws of Kepler. Now third one. Okay, what is third law of Kepler? What is third law of Kepler? So see, what is third law? 3. It is called law of periods. It is called law of periods. What is law? What is law of periods? See, first of all, to write its statement First of all, to write its statement, remember one equation. From that equation you can easily write its statement, that is t square is proportional to AQ. T square is proportional to AQ. What is T? T is time period. You know that what is time period? It is time taken by planet to complete one revolution around sun. What is A? See here, A. What is 2A? It is major axis. So what is only A? Only A means it is called semi-major axis. It is called semi-major axis. 2A means it is total major axis. A means it is semi-major axis. So if you remember this equation, you can easily write its statement. How to write statement? See, here it is. Okay. Here it is. Here it is. Okay. Square of time period of planet around sun. Square of time period of planet around sun is directly proportional to cube of semi-major axis. Square of time period of planet around sun is directly proportional to cube of semi-major axis of ellipse on which planet is revolving. So yes, it is statement that you have to remember. Okay, T square is proportional to A cube. T square is proportional to A cube. T again time period. T means time period. It is time to take. It is time to complete. Time to complete one revolution around sun. And what is A? Yes, A is semi-major axis. It is semi-major axis. Clear about this? Okay, so yes, law of period. T square is proportional to A cube. Yes, see, this T square is proportional to A cube. It is for elliptical orbit. For circular orbit, we will prove. Okay, we will prove in this chapter. See, this first law, it is already given. This second law, we have proved in chapter number 7. And this third law, that is law of periods, we will prove this in this chapter. Okay. We will prove this statement that T square is proportional to A cube. Okay, from this equation we can also write that T is proportional to A raised to 3 by 2. It is A raised to 3 by 2. Yes, T is proportional to A raised to 3 by 2. Clear about this? So yes, these are 3 laws of Kepler's law, law of orbit, law of areas, and law of period. Okay, and yes, it is one important question for 3 marks, first, second, and third. Clear about this? Okay. Now we will see one question. See, example 8.8. You are given one planet which is revolving around sun, an elliptical orbit. Perihelion, aphelion, major axis, BC. Okay. Let speed of planet at the perihelion P is Vp and distance from sun is Rp. Distance from sun is Rp. Okay. For aphelion, it is VA and RA. Means speed of planet at point A is VA, and its distance from Sun, it is RA. So first question is, what is the relation between these quantities? Here speed is VT, here speed is VA. Then what is the relation between them? Okay. See, in chapter number 7 we have proved that whenever a planet is revolving around the Sun, it is revolving due to gravitational force. So line of action of force is passing from Sun itself. So torque is 0, and torque is 0, then angular momentum is constant. Then according to law of conservation of angular momentum at point P is equal to angular momentum at point A. But first of all, what is equation of angular momentum? See, angular momentum, wait a minute, okay. Angular momentum is equal to, it is linear momentum into perpendicular distance. So here I can say L is equal to, it is PR, okay, and therefore it is L is equal to, P means it is mvr. How I can write directly PR? Because we know that velocity at each and every point, it is in direction of tangent. So between P and R, angle will be 90. Between P and R, angle will be 90, and sin 90 is 1. Okay, so L is equal to mvr, where m is mass of planet. Right, mass of planet. Planet is at point P or at point A, its mass same. Its mass same. Okay, only P and R changes. So now, according to law of conservation of angular momentum. According to law of conservation of angular momentum, LA is equal to LP. Simple. Angular momentum at point A is equal to angular momentum at point P. So yes, MVA RA is equal to MVP RP. Why MM? Because mass of planet remains constant at each and every point. So M cut. Simple. Okay. Now if I make VP as subject, then VP is equal to, it is RA upon RP into V. Clear? Is it visible? Yes, it is visible. You can easily see it. Okay, yes, you can see it. So VP is equal to, it is RA upon RP into VA. Now from figure, see, it is clear. RA, RP. What is clear? RA is greater than RP. Please clear. RA is greater than RP. Yes or no? So if RA is greater than RP, then this ratio is greater than 1. Then obviously VP is greater than VP. VP is greater than VA. How to relate them? Do you understand? Okay. If RA is greater than RP, then VP is greater than VA. It means when planet is at perihelion, its speed is more than its speed at A. Yes? And now you know relation of speed with time. If speed is more, time is less. Yes or no? Yes. Yes, it will take small time. So here it is simple. See, it is Sun. This B is the distance. To travel this distance, its speed, it is less. It is small. Yes or no? So if speed is less, it will take more time. Why? To travel this distance, that is CPD, as this distance is, or this region is near to Sun. And near to Sun, its speed, VP, is more. Speed is more, that time taken is small. Okay, so simple. As VP is greater than VA, it will take more time. more time to cover distance BAC than CPD. Clear? So time to cover BAC is greater than time to cover CP. Clear? It depends on, obviously, it depends on speed. It depends on speed. Clear about this? Okay. So yes, this relation of time you can easily understand with the help of speed. Okay. So this is one example 8.1 which is based on this KETLER'S 3 laws. Okay. So this is it for today. See you soon. Tata. Bye bye. Okay.